Hello, this is Daniel, and we've got quite the project or undertaking. I've been working on it for the last few weeks, and this is definitely the most confusing thing I've had to configure. It's basically a Fabric plus Fabric 1.1 with TLS, with KAFKA, with multiple orderers, all in different machines. So you can imagine this is pretty hardcore. We're not messing around anymore. We're just going straight to production. So let's. I'm just gonna. God, what's going on here? Oh, okay. Let's just download this real quick. Um, and actually, before I sort of jump into everything, I'm gonna give a short rundown of the code because um, actually, I'll have the code on this side, but I want to get the Terraform thing started as soon as possible. Okay. We'll go to Terraform, and just like the last um, thing I had, where I had Terraform initialize the AWS machines, I'm just gonna do that for this one. Terraform plan, and then Terraform apply. Alright, so that's running. Um, so while that's running, I'm just gonna take a look at this. So if you notice, sort of the composer directory is empty, and there's a lot of things here. That's because these Python scripts will actually create the files necessary based on how many peers you want. So what I do is I'm gonna show you this Terraform script real quick. This variable n stands for the number of machines that you're going to end up with. And basically these Hyperledger Fabric files, basically this entire set of things is going to be on a EFS file system, which basically functions as an NFS between the n instances you will create, and will contain all the data for them. So what I do is I run this script called start.py, which basically is a Python script that runs all of these config all scripts, which in turn build all of the files that will be within Composer. So I'm just gonna quickly show you an example of Docker Compose peer n. Structure is pretty simple. You have your it basically runs in a loop for the amount of peers minus one that you need, because these scripts only run if you have, like, of course, two or more peers. Otherwise there's no reason to generate. So we have basically it looks like your average Docker file for a second peer, but just sort of added numbers as sort of the small changes within a very sort of normal template. You can look at the specifics of the KAFKA and the Zookeeper and all that other stuff on your own time, but one thing I do want to highlight, which is the main sort of linchpin to getting all this stuff running, is this helps, of course. You put your Kafka brokers obviously within the Kafka brokers location. You change the order type to Kafka. Oh yes, and you add the orderers to this addresses list. And what I've done is, depending on how many additional peers there are, it'll add orderers. So this would be IP host 2 and would be replaced by the IP of the second machine in that case. This would get replaced by the IP of the first machine. So, config tx is big. Also crypto config. This is one thing I learned while looking at the default crypto config file. Let me see if I can sort of find that. Because I remember when I saw this, yeah, if you run CryptoGen show template, it'll give you a bigger list of the CryptoGen commands, and you can actually see what is possible. So this sans basically allows you to add IP addresses to the hostname config, allowing you to specify what on which IP your orderers or your peers are inside. And basically this specifies that the first orderer is in the IP host 1, second orderer will be within IP host 2, and so on. And this adds IP host 2, IP host 3 for the amount of nodes we have. And you may have seen this from my last, but this basically replaced all the bracket IP host with the actual host name of, or with the actual IP address. But I can show that to you later. It looks like the resources are configured, so I'm just gonna go to my AWS console on another screen. I put 2 nodes. There are 2 nodes specified in the Terraform install by default, so we're going to SSH to peer 1. So I just copied the actually, let me show you this real quick. I just copied the public DNS of the first host, which has an IP of 192.168.1.5. 192.168.1.5 is the first host as specified by my Terraform configuration. You can't use by default, Amazon uses the first 4 IP addresses of a domain range, so you can't use you can't use 1, 2, 3, or 4. So I was able to do this, copy this DNS, SSH to Ubuntu at this location, and you'll be able to do it. Oh, one thing I forgot to mention was the fact that the Terraform script by default, where is that Terraform script? Yeah, it takes the public key found in your home .sshidrsa.pub, so you can connect to with your public key, but if you tried this from another computer, it would not work. And this only works in Linux. If you want to add a different public key, then obviously you'll need to change this, whether you're using Windows or Mac OS. But yeah, this is a platform agnostic install, since we are using Terraform to deploy Ubuntu images onto the cloud. So I don't even know if this is actually the same. Okay, good. This is different. Okay. Now, I'm just gonna move this here. We don't need this for now. And I'll put this right here. Let's get that Terraform install running. Move to the Terraform location. We did all this on the first machine. See, oh, that's one thing I should notice. Obviously, CD to the directory. If you compare this to my my project, we have install prerequisites, all this stuff. We don't have create peer admin card, and we don't have start fabric peer 2. These are created by this template. And also, if we go into Composer, you'll see that there are a lot more files instead of the just the one Docker compose. You'll see that. Let's go to crypto config real quickly. You'll see that this hostname order 1 is added. And this sans is also added. This is added along with this whole area. Okay. Then we want to chmod the how to build, and then run it. Okay. Now that's done, we can, oh, where was this? Yeah. CD here, and then start fabric. While that's being done, let me do a real quick this is one annoying thing you might have to do. You need to change you have to add this hostname entry to every peer that you have. And I do this just so that in basically in start fabric peer 2, we're going to need to connect to order 0. So in order to do that, we can't use IP addresses. I've tried that before. It doesn't work with TLS. Although I could try it now to see how it works with those sands. But just to be safe, this is how it worked with my config. So I add the hosts file entry, and this works. Let me chmod this. Oh yes, one thing I feel that I need to explain is the fact that even though we connect to the first orderer, we actually use the TLS certificates of the second orderer. I don't understand the mechanism behind that completely yet, but my hypothesis is that because of the sands that we have within crypto config, since the second peer has an IP address matching IP host 2, there's sort of a what's the word? There are issues when trying to use the orderer 0 TLS certificate because it has a sans with an IP of the first host machine, which is 1.5. So that's sort of my one sort of issue with this install is I don't understand why it works, but as you will see in a few minutes, it does work. But the GitHub link will be posted on this video, so feel free to fork it. I know a lot of you who watch this video will fork this repo because it's pretty freaking cool. Not gonna lie. This is one of the coolest things I've made, especially since it's end machines plus KAFKA and multi-order. It's like, okay, how many new things can you introduce with a Hyperledger infrastructure install? Like, just gotta, it's like, I don't know, after this, what can you really do? Maybe after this, maybe I'll like make a full self-healing distribution on Kubernetes or something like that. I don't know. Honestly, after this, it would be nice to sort of look at other technologies such as Sawtooth. I know I've been sort of looking at Sawtooth pretty recently, and it looks cool. Seems like a more put together solution. Well, I don't know about more put together, but like you have to define things really Actually, you know what? I haven't read enough on Sawtooth to try to explain it, so just disregard everything I said the last few seconds. And this creates the peer admin card. Like the other things, this peer admin card um, also changes depending on how many peers you have. And once this is done, let's run Composer Playground. Okay. Let me just make sure I have my the correct host names for the Hyperledger instances. What I've been able to do is actually run Hyperledger Composer um, on both machines. Um, you can basically what happens is actually I'm not gonna explain anything. I'll sort of just show you how it works. Can I just like, oh man, can I not just take off one tab like I usually do? Nope, I guess I can't do that right now. Let me just delete these tabs for now. Oh, I need that. Okay. This is gonna annoy me, so I'm just, wow. Okay. My computer has AIDS. I don't know what's going on. That's okay. I'm just gonna upload a random, where is it? Trade network. There we go. Okay. I'll upload this trade network. We'll just put some enrollment ID in secret. Deploy this. Let's see if see if anything's happening here. It's gonna take a while to load. It basically deploys the business network on all peers, but you won't be able to see it within the second Composer instance. This is because technically you can't reach that instance unless you have the business card associated with the network deployed. So once this business network is created, what we can do is export that business card and look at it using the second peer. So let me just reiterate that. Create the network with the first machine, export the card. So we created it. Let me connect and do some things with the connection. Okay, so now we have test. Let me just create two trading participants real quick. Just so it's something it's differentiated, and we can see this network in action, which I'm sure you all want to do. Okay, so we created those participants. Let me just get this commodity. Okay. So this is owned by Trader 1 so far. Alright, I'm gonna go back to my business networks. I'm going to download this business card. I'm gonna save it. Where's it saved? Admin 1 card. Gonna go here, import business network card. It was admin 1 card. There we go. So we have that. We can import. There we go. It was imported. We can connect to it now. Let's look at the test. So we have the Trader 1 and Trader 2 that we created last, and we have Trader 1 right there. So let me just submit a transaction. Right here. Oops, just hit my mic, sorry. We'll submit that. Go back to test. The commodity should be Trader 2 now. Let's go connect to this trade network. So this should be in Trader 2's hands at the moment, and it is. So you can see that blockchain works, and you can use both these instances of Composer to observe the state of the network. Obviously, using Composer to run business networks and not using the REST API is obviously not the greatest of ideas, but this gives like a foundation for you to test things on.